Welcome to another episode of the Co-Extrusion Podcast. How you doing, JJ?
I'm doing good.
Good. Okay, so let's get straight to business.
Yes, right into
I
it.
have a project that I have been working on for 3 weeks now, 4 weeks now.
Yeah.
I'm using 3D printing for it, and it is the single biggest 3D... I don't want to call it a 3D printing project, but I'm heavily utilizing it. And
Yeah.
it's probably the biggest project I have ever taken on.
Whoa. Yeah.
So I am completely restoring my first car, actually. So it's a
Ooh.
BMW Z4, and I'm using 3D printing to restore a lot of the broken plastic clips, a lot of the any other miscellaneous broken pieces of plastic that don't exist anymore or
Yeah.
just completely need to be refabricated. And why I got this wonderful idea, because it's been
Yeah.
equally enjoyable and miserable and the most challenging project
Oof.
that I've ever taken on. So, for instance, and this is just randomly sitting on my desk, but like one of the pieces for this car, it is
Like a little bitty.
yeah. So
Yeah.
it's curved, and I'm not getting it to focus very well.
Yes.
It's a curved piece, so I need to figure out the curvature of it. But it also has just very you can see
like little bits to it.
Yeah, so like these inner pieces, they're different widths and dimensions, and this isn't even a clip that existed. This is a piece on the car that was like injection molded into another panel, and something like fits into it, and it like kind of press clips in, but it did plastic is plastic. The car's 20 years old.
Yeah.
It gets brittle, it breaks, and then it just poofs and no longer exists. So then
Oof.
the piece that mates into it doesn't mate into it anymore. So like when you touch it, it's like or it's loose.
Yeah.
It's squeaky, it's loose, and body panels don't fit together. So
Oof.
this is what I've been doing.
Yeah, that's a complex, cars are very complex.
Yeah. Well, the crazy thing, and so I've got all the CAD pulled up now, and unfortunately I'm not really going to be able to show the CAD on screen. It's just technically difficult, but I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 12 different mounting clips or brackets or things that I've had to design and somehow affix to these body panels. And
Yeah.
it's an interesting project for me because if I've said it once, I've said it 100 times. I'm an engineer. I love solving projects. And this is just a gigantic. Sorry, I love solving puzzles. This is a gigantic
yes.
puzzle and problem to solve because some of these clips, like, I don't even have references for them in the vehicle. So, for instance, I'm having to. So when you have a clip, you've got like a male end and a female end, and they mate together. Well, for instance, if the female end is missing, all you have is the male end to reference. Now, how do I reference this to make it mate in and design a replacement for it?
It's like a puzzle, but you only have half the pieces, and you have to design the other half. Yeah,
exactly. And so it's
interesting.
It's this like mind twist. And in a couple places, I've had to actually resort to completely redesigning parts from scratch. Like, for instance, this piece, the single most complex piece, did not exist at all. Like, I didn't have anything to go off of except images online.
Oh, wow. Yeah.
So I've done that as well. I've gone online in order to reference images, and I think the only way that I was able to make a piece like this actually function is because this whole thing is designed parametrically. So for a lot of people that don't understand parametric design, I don't know if I can give you an exact definition of it, but essentially you can go back through the history of all of the steps that you've gone through,
Yeah.
you can change a dimension on like, step 2 and it propagates all the way through to the end. So if you
Mhm.
did 15 more steps, it'll just propagate through and it'll just like magically update. I don't know, right?
Yes.
Do you have a
Yeah,
better
yeah.
way to
Based off of programming off of sort of off variables, but off of
yeah.
parameters that you can go back and adjust those parameters that you're working with, versus I don't know what the opposite of parametric modeling would be. Like
I
uh,
don't know, yeah. There's
Blender, how I model
Blender
in Blender, it's like, okay, I move this vertex over here and now it's there.
yeah.
Uh,
Well,
yeah.
so like for instance, this piece, everything is a variable. So
Hmm.
I use Fusion 360. I went in and I made, or they're called parameters in Fusion 360. I
Yeah.
made parameters. And so I would get my calipers and I would go and I'd measure this piece, and I'd measure all of
Hmm.
the depth of the curve. So like, I got point A, point B, and how deep does the curve go? Because I
Mm.
know I want it to be an even curve.
Yeah.
And so I'd measure all those things and I'd put them into the parameters and I would just kind of cross my fingers, hope for the best. And I would print it and I would take that printed piece and I would mate it up to the body or the trim panel.
Hmm.
And I would check, okay, does it fit? And if it doesn't fit, I'm like, well, back to the drawing
Go
board. I
change it
probably
again.
printed this
Yeah.
piece, honest to goodness, I probably printed 15 or 20 versions of this piece
Yeah.
because this is like pure reverse engineering. Like,
Hmm.
there's
Yeah.
nothing is trying to make something that doesn't exist, essentially.
And luckily, it's a print that would take you 5 minutes to print. Like,
Yeah,
that would be such a fast print to like bang another one out, change variable, print another one, change, print another. Yeah.
100%. And that's actually like kind of where I wanted this conversation to go is almost
Yeah.
exactly that because for everyone watching, like you might not be interested in, oh wow, Jerry's fixing up his BMW. Like that might be a
Hmm.
boring conversation, but the place that this conversation can go is like this can be done in 5 minutes and
Hmm.
you can test fit it. Now I printed everything in PETG, but you could print them in PLA in,
Yeah.
test fit. Okay, it's good. Now go print it in nylon or go print it in
Hmm.
whatever stronger material. And, you get your 5 minute PLA prints done and then go into something more strong or everlasting, what if you
Yes.
will. And like the big thing here is any body shop can take any car, like a car from the 60s, a car from the 50s, where parts are quite literally like non-existent. They
Yeah.
not only are they non-existent online on eBay because there's very few of them that like
Ever existed.
that
Yeah.
yeah, but like if you go to Chevy or Ford or whoever, they're not gonna be able to manufacture this piece anymore. So like
Yeah.
what do you do if you're trying to fix a car, restore a vehicle, anything?
Hmm.
Don't forget about cars.
And
If you
even if
have
that clip was manufactured and sat on a shelf for 20 years, it's probably still trash now. Like,
exactly,
yeah.
exactly. Now and I'm confident you've seen this video and probably everyone watching has also seen this video. The video that introduced me to Morley Kurt was him 3D printing a part
Hmm.
to fix his typewriter, an unknown branded I don't know, if
Yeah.
some random typewriter. What are the odds that that part existed for purchase or
Hmm.
whatever? He went
Yeah.
in and he fixed. Now I don't know if it was an expensive typewriter. It doesn't really matter if it was.
Yeah.
But if it's something that you want fixed, that's what 3D printing is like. That's what it's perfect for.
Yeah. Oh,
And
yeah. The custom fits to it and the ease of those. I think it's helped me for doing CAD because I don't have a background in CAD. I haven't done a ton. But whenever I do need to make something that fits together, I can in the slicer or in the CAD program slice off just the mating surface there and then print out just the clipping parts
yeah.
and print it in 5 minutes, try to make it clip, print it again, try to make it clip. Cool. When it finally works, then I'll print the full part with the clip
Oh,
attached to it. Yeah.
100%. 100%. And like for me personally, like all of the pretty much everything that I've been printing has been small. So
Mhm.
it would actually probably be more work for me to design the whole part, but only print the mating surfaces. It
Yeah.
would probably be more work to do that than just print the whole thing and test it. But I mean, it's like 10 or whatever I said before. It's a lot of designs I've kind of like had to just, you know, curate
Make out of
from
nothing.
nothing.
Yeah.
And it's like one a lot of these parts are relatively simple.
Mhm.
And I wish I had a pile of them. I guess I was ill prepared for this. I wish I had a pile of them so I could show you, but it would be like, you can't see
Yeah.
because it won't focus on them. They're so small. But the process has been actually really fun because it's a bunch of small wins because
Mm.
most of the parts are being fixed on to the body. I've been grinding it down to make a rough surface, and then
Mm.
I fix it with like a 2-part JB weld
Yeah.
essentially. And after you affix it, then you can do some sanding and grinding down to. So it's been, for the most part, relatively simple, but all those small wins culminate into, like, a really fulfilling feeling.
Oh, yeah. Like,
Eh
the pure genesis of CAD, like, when you have created something from your brain to CAD to a 3D print, that's a huge, great feeling. Yeah.
well, I think a lot of people that 3D print, and this is absolutely not knocking anyone for that. Some people just
Mhm.
totally don't care to print functional items. That's, like, where I am at my core. That's what
Mhm.
I've like, probably 90% of my entire 3D printing, like, history or whatever is either designing and printing functional prints or downloading them from the internet and print, just solving
Mhm.
problems. And this is a way that I've been able to just solve tons of problems all at once, right? And when I'm done, it's gonna be like a completely fully restored vehicle. Like it's it's
Yeah.
it's crazy.
That's crazy. Like, to totally be able to make something that doesn't exist out there right now, and now
Exactly.
you've made it. It
Well,
exists now because of you.
I know, and one thing I was thinking, there's a I in this process, I've joined a bunch of BMW Z4 community groups. There
Mhm.
are a lot of people that have these cars. The
Yeah.
parts for these cars aren't it's not like they don't exist,
Mhm.
but one part like the size, one part like the size of this lens cap, like a tiny part
Yeah.
is like $50, right? You know, when
Yeah.
you get up to the size of this box, you're talking between 75 and $100. So
Yeah.
if I'm trying to fully restore a vehicle from start to finish and it'd be like perfect and pristine, I'm gonna spend more money in used parts that are
Yeah.
still probably broken in one way or another because they're still 20 years old. I'm gonna spend
Mhm.
more money doing that than it would be to just like buy a new car.
Yeah.
So like my outlook on it is I'm trying to save money.
Mhm.
It is fun. It's frustrating doing it, but it is fun
Yes,
as
for
well.
sure.
But like what if these parts don't exist? What if you're
Yeah.
so
They don't exist, and that's cool at the end that you have them, of now you could, uh, sell or whatever you wanna do with the files and models that you have at the end of it, like, yeah.
exactly. So this is probably a situation in which I would most likely just publish the files online
Mhm.
for people that want them to do the work themselves. I don't know if I would go as far as to sell the individual parts. That's like I'm doing this as a passion
Yeah.
project. I don't
Yes.
want to charge other people that also have a passion to fix up their vehicle.
Yeah.
But totally, like
Mhm.
I mean, anyone could download these models when I'm done, and then
Yeah.
if they only wanted to, they might not want to be getting into a full, 2 or 3 month long project of full vehicle restoration. They might just want to fix one part at a time, you know?
Mhm.
And uh they couldn't do it before, but now they will be able to. So
Yeah.
it's interesting.
That's really cool.
And this kind of also like plays back in my head a long time ago. I don't know if you ever watched the show, and I don't remember what it was called, but it was a show online where people brought random odd things to this company and they walked you through the process of restoration.
Hmm.
Um, it
No.
was a reality show, but you could bring them anything. You could I watched videos where they got brought gas pumps and old sewing machines and
Mm.
this
Yeah.
and that. And these people, it's like you bring them something that's sentimental. It's not like
Mhm.
it's not like I want this to be fixed because it's worth money. I want this
Yeah.
because this is a sewing machine that my grandmother used to make
Means
my
something.
clothing when I was a kid. And I want
Yes.
this very exact specific sewing machine restored. And I watched it. This was a TV show. It was like 10 years ago, 15 years ago that I watched this.
Mhm.
They were not 3D printing parts.
Yeah.
They were
How much easier the
fabricating.
show would be nowadays.
They
Like,
were fabricating, like, anything metal had to have been, like, milled by hand.
mhm.
Now, design it in CAD, print it in plastic. If it fits, send it off to a company, get it printed in metal, or
Yeah.
you could have your own CNC machine, print it in
Mhm.
plastic. When it's done, put it on a CNC machine.
Yeah, CNC it still in your garage and you have it. Or you could there's like the tough resins that are out there for resin printing or the carbon fiber nylons that print on most consumer printers are
Probably good
really
enough.
tough.
Yeah.
Yeah.
So, I mean, that really is that's actually really a good point. Like, a lot of these parts, forget my project. The project, like, a lot of these projects that people want to go through with restoration, things were made out of metal 20 or 30 years ago because that might have been the only method, right? Like,
Mhm.
milling it might have been the only way to do it. You might not have been able to get it in a small run of these parts in plastic,
Mhm.
but now, sorry, a small run of these parts in plastic that was durable. But now
Yes.
you
Yeah.
can print plastics that are strong.
Mhm.
Why not?
Yeah. Yeah. The one-offs are like getting 10 parts out of plastic is now doable versus in the past it was like no, like you can't get 10 things made out of plastic. Like we need to make a die that needs to get injection molded, so you have to do 100,000
Yeah,
or you can't get it in plastic. Yeah.
yeah. And actually, maybe where I think it was you that was with me, when we were looking at, oh, who was it? They were doing the SLS printing of the plastic parts. What company was that? Uh, oh,
Y-
you
uh
my brain's not working, but
yeah,
those
all of those
parts
brands.
were SLS. I think that is it. It's SLS, not
The laser,
yeah. But so
yes.
there's one for plastic and one for metal. I think SLS was plastic.
Mm, yeah.
Um, those parts printed in plastic with a laser, they looked like they were injection molded. Like,
Yeah.
I mean, you can use them as like final design exterior
hmm
panels.
Flawless. But they're still 3D printed, so you can have the complexities of 3D prints in a way
100%.
that you can't injection mold every shape you want. Yeah.
100%. And the thing with SLS printed parts is you have a lot more powders to choose from, especially
hmm
more engineering grade durable powders. So you can print parts out of plastic with an SLS machine that are going to be more durable than printing on a standard FDM machine. So
Yes. Yeah.
let's say you need something that is as strong as a solid injection molded piece of ABS, which I don't know how strong it is. I don't know, but
Yeah.
you can do a run of two or three parts in two or three. That's it in an
Yeah.
SLS machine. Whether you're a business and you own an SLS machine to do all these one-off custom parts,
hmm
or whether you send it off to someone and get it back. Like, I don't know. Like,
Yeah.
there's these real world applications for 3D printing, and I've kind of knew that. I mean, I knew they existed, but getting into this directly,
hmm
working with it and fixing up old car parts that don't exist, it's like it's reliving it for me and or it's bringing it all
Yeah.
back. It's bringing it into reality is what it's
Yeah.
really
I feel
doing.
like diving into CAD is one of those things like if you have a 3D printer, I would highly recommend because whenever I do get into recently, I got it back into CAD with so I 3D printed that loom that we talked about a few weeks ago, and so then I started looking on designing a larger one, and so like diving into CAD, and you're just solving all these little problems, and it honestly like was scratching that itch of playing a video game where like it felt like I was just in this 3D world making decisions, making like design changes of like, oh, how does this interact with that, and like solving this big picture puzzle in this 3D world that I was building. And it's like, this is such like I'm just playing a
Yeah.
video game right now. Yeah.
100%. And I think so. Like for instance, I have designed cabinet locks for every cabinet that we have in the house because
Mhm.
the cats like, and I might have talked about this before, but the cats like to walk up and they're strong enough to pull the cabinet open, but we have soft close hinges, so there's a little resistance. They
Yeah.
can't get it all the way open, so they slip and it falls and it goes for 30 minutes straight. So I designed cabinet locks. These are
Yeah.
custom locks that are non-destructive to the cabinets. No drilling, no
Mhm.
adhesive tape. They're they're mechanically just fit. And I probably designed these locks in like 5 or 6 minutes. That's how
Mhm.
simple they were. But getting into CAD for anyone listening, like it really is a game. It feels like,
Yeah.
especially in those bursts of whatever chemical get released in your.
Dopamine, those enjoyment
Yep,
dopamine hits when you're like solve it. You're like, "Oh, I got the puzzle right. I figured it
exactly.
out." Yeah.
Exactly. That's exactly what I was gonna say.
Yeah.
100%. And it's like, I just did that and I solved it and it was fun.
Yes. Yeah.
And here we are. And what's crazy to me is when I started 3D printing, the very first time,
Mhm.
like when I got my first printer, I and this is gonna come full circle in a second. I wanted to sell 3D printed parts that I designed so I could
Mhm.
pay for the cost of the material so I could print myself for
Yeah.
free. But the truth is, printing is so cheap.
Yeah.
It's like once you have the printer can be expensive.
Mhm.
We just talked about the Spark X behind you in the last episode.
Yeah.
$340. So it can be cheap, right? But
Yeah.
it can also be expensive, right? If you get a $2,000 printer. Once you have the printer, the cost of material is so dirt cheap.
Yeah. Because everything you print is hollow, so it's like that's the one thing I feel like a lot of people ask of like, "How expensive is it to make that?" And I'm like, I always say $20 a kilogram, and so you weigh this and it weighs, I don't know, so little.
Yeah.
Because everything is hollow, so
That present probably costs certainly less than a dollar, probably less than 50 cents.
yeah.
And the end, this piece that I was
Mhm,
telling you
yeah,
about,
oh, that.
this piece, take a guess how much this cost. 3
Oh,
cents?
yeah.
2 cents? Okay,
S nothing.
probably 2 or 3 cents. If you add up and culminate I probably printed 15, 20, 30 of these things. If you add up all of them, probably less than $3.
Yeah.
And for me to replace that part,
Oh,
it's like
yeah.
$300. And
Yeah.
there's no promising that the used one that I get in the mail is even good.
Is gonna
But
work. Yeah.
so like but it's just so cheap. And I
Mhm,
thought it was expensive when I first got into the hobby. I didn't
mhm.
realize how far a 1 kilogram spool of filament really
Yeah.
got you.
Yeah, because there's so much that you can just do with a spool, like, it just keeps going and going
Well,
and
well, and so that's another reason why I almost recommend people to just get a spool of like PETG or whatever, or
Mhm.
ABS glass filled, something strong and rigid and durable.
Yeah.
Even though those materials are $150 a kilogram, usually manufacturers like Polymaker will sell them in the quarter or the half kilo.
Mhm.
And a quarter kilo of that stuff, a half kilo is going. I mean, if and of course I literally just snapped this because I have ADHD. I'm fidgeting,
Yes,
but
yeah.
like this piece, like if you're only printing this one, like I said, print the test
Mhm.
pieces in PLA and then you print the final
The final
one
one.
in a more
Yeah.
durable material, and then now your $150 roll's filament goes, I mean, it lasts you for 2 years or more.
Yeah, you're using that print would probably be 5, 10 grams, like, that's nothing.
This print I think it's like 2 grams or 3
Oh,
grams.
wow, yeah.
3 grams,
So
even
even
as
less.
solid, maybe 4, whatever,
Yes.
it's nothing.
Nothing, yeah.
Um, so it's like, I mean, the world that opens
Mhm.
from someone knowing how to use CAD.
Yeah. And I think the amount of easy CAD there is out there of, like, I didn't love Fusion 360. I think Fusion 360 is a huge for an engineer, it's great. For someone who loves that, like, parametric mindset, it's great. But Blender, I think, is great for a lot of people who are kind of a different mindset. For me, it worked great. Or even Tinkercad. I've seen some crazy things people have made in Tinkercad, which is like an online program where you're like putting blocks together. But if you get good at it, you can fully design elaborate things that people have made, just combining boxes and spheres and subtracting and like I don't know how they
My
do it, but it's
my
crazy.
brother-in-law made a hinged Magic the Gathering card case in
Yeah.
Tinkercad, like a print
Wow.
in place hinged lid, and I'm like, that took a little bit
That's impressive. Yeah.
with the amount of time and skill that took, you probably could learn a software that's a lot more capable. But the
Mhm.
point is,
But
with
he was able to do it
with
in a
Tinkercad, if
free online program. Yeah.
exactly, and if you know how to use Tinkercad and you only want to do this one thing, it's possible.
It's possible. Yeah.
I think I think knowing CAD, any CAD, if it's as
Mhm.
basic as Tinkercad or if it's as advanced as Fusion or Blender, if you know any CAD software, it's going to, like, let's say you're moderately capable. You don't have to be
Mhm.
perfect. You just have to know enough. Because once you're doing your design work, if you have a hang up, you can go to YouTube and figure out your problems.
Oh yeah.
If you're moderately capable, you're gonna walk around your house and you're gonna see, like, this can be fixed or this can be upgraded or this,
Yeah.
and your list is just gonna grow, and
Mhm.
it's an endless list of, I can do that.
Yeah. And customizing things is the best feeling of like taking a 3D print that someone else designed and being like, "Oh, I want to make this a little bit bigger or longer or rounder.
Oh,
I want to
sure.
attach two parts together." And a lot of that you can do with the slicer, but CAD I think makes that even easier and even more powerful.
Yeah, I mean, it's definitely a tool that opens the doors for a lot of people. Like,
Mhm.
for individual consumers like us, it opens the door for individual consumer level tasks and products and, or sorry, tasks and projects. But
Yeah.
from a professional standpoint, I think I think anyone that deals with modification of parts, upgrade of parts, if you're not if you're not getting into the realm of CAD and 3D printing, I guess a lot of those people are already using CAD to do mock-ups,
Mhm.
but they're
Yeah.
not using it for manufacturing. If you're not getting into the manufacturing aspect of things, like, someone else is going to get in your ball game, or someone's going to get in that ballpark, and they're going to take you down. Like, it's just going to happen
Mhm.
because there are things that you can 3D print that you can 3D print it in a tenth of the time that it would take to
Mhm.
manufacture by hand.
Mhm. Yeah. Or even from the consumer point where I can make something faster than Amazon can ship it, where it's like, "Oh, I need this little clip right now." And I could have it I can even find the file online, modify it to work perfectly for me, print it out faster than I could get it shipped, and it'll be way cheaper anyways, so,
Yeah, I was just looking
yeah.
for my desk organizer, which is what you would otherwise buy on Amazon, because
Yes.
where else, like, why would I, but
Mhm.
there's hundreds and hundreds of desk organizers. There's probably more desk organizers on printables than there are on Amazon,
Yeah.
because the ones on Amazon are rebranded and different colors from different sellers that are just buying from the same manufacturing plant.
Yes,
But
yeah.
printables, they're, yeah, it's endless. I mean,
Mhm.
it, I don't know.
It's cool. It's a wild world out there.
It really is. It really
Yeah.
is. It really is.
Nice. Well, I think that just about wraps up our conversation.
I think so. Yeah. Hopefully, I didn't like just completely bore everyone with my rant at the beginning. I get just
No, I think it's really interesting. And let us know if you thought it was interesting or if you've done any bigger projects involving 3D printing or fixing up cars or whatever. Let us know in the comments down below. We'd love to talk with you.
100%. We want to know how you guys are using 3D printing in your world or in your life as like functional. So
Yes.
put some comments down below. And we are here to reply and have conversation.
Yes. And be sure to like and subscribe. Videos every week. That's
I
the
think
end.
that yeah.
Bye.